Hi guys, welcome to Mr. Hescock's Physical Science Chapter 1. We've just started the pretest. We've done the vocabulary for Chapter 1. Now we're going to start talking about properties of matter. Review from the last section. What is matter? Matter is anything that has mass and takes up space. You will have a little bit of homework tonight. You'll have some reading I've converted your worksheet to a Google form and it will be waiting for you in the classroom. So let's talk about matter. Without looking up the answer, write your best definition of matter and then share your answer with a partner. So if you think about it, name some things that are matter and then describe them. And I know you know the definition. So matter is something that has mass. Well, mass is how much stuff you have. And volume is how much space it takes up. So the difference between mass and volume, mass is how much stuff is inside an area, and then the actual area is the volume. Matter has mass and volume. Matter is what makes up all objects, living and non-living, in the universe. The picture behind you is a picture of our solar system. Matter is anything that has mass and takes up space. Space is emptiness. It is the lack of matter. Light, sound are also not matter. Energy is not matter. Properties of matter. Mass is a measure of how much matter an object contains. We, in America, typically use the word weight incorrectly. Weight is a matter of mass with gravity applied. When we're asking how much you weigh, we should be asking how much mass you have. I grew up as a wrestler. We were always checking our weight, but we should have been checking our mass. Mass is how much stuff is in there. So, which has more mass, a plastic spoon or a metal spoon? Well, you think which one's heavier? Obviously, the metal spoon. Mass is measured in kilograms or grams. Grams is technically the base unit in the metric system, except it's so small, it's only about the mass of a paperclip. So we tend to use kilograms, which is actually 1,000 grams. To measure the mass, we use a balance, an electronic balance or a triple beam balance that we'll get to in a day here with our measuring activities. Weight is different from mass. Weight is mass, which you have how much stuff, with gravity pulling downward on you. You cannot have weight without gravity, which is why in space you can be weightless. Weight is measured in newtons. Newtons is actually the same unit that we use for force. The more mass an object has, the more gravity can pull on it. I'm a big guy. Gravity pulls down pretty hard on me. Weight is not constant, but changes as gravity changes. If you had a weight of 100 newtons on Earth, you're not very big, but say you weighed 100 newtons, you would have a mass of 1/6 that, which is what, like 16 newtons on the moon. If you had 150, you can kind of do the math, you just divide by 6. If you would go to an airplane and take your weight, you would weigh less on the airplane than you would here on the surface of the Earth. The further away you are from the center of the Earth, the lower the gravity and the less you'll weigh. Your pant size won't change at all, but you would weigh less. Volume is a measure of how much space something takes up. You can have a lot of mass in a small volume that we call density, real dense object, or you can have a lot of space absorbed by something that doesn't have a lot of mass, like a basketball. Most of the inside of a basketball is air. Styrofoam takes up a lot of space, but it is mostly air inside plastic, so it doesn't have a lot of mass in there. Air is very, very separated particles from being a gas. This is a graduated cylinder, and we use graduated cylinders to take the masses of many things. You can measure the differences in the two amounts of water when you subject your object to being inside. The other way that we typically use, especially if you go to shop class, length times width times height of a rectangular box. That you could also use this displacement method. Displacement means to push away. So you read the initial volume and then you insert your object and you subtract. You subtract the initial volume from the final volume. So if this is my beginning volume, here's my final volume, and I have this object inside. This right here, maybe it's 2 milliliters, is my volume. All right, ladies and gentlemen, that gets us to the end of this first section. Make sure you get your work done. You guys be good. You be safe. Until next time, I'm Mr. Hescox. Thank you.